Well, hello guys. It's been a while. I'm done with vacations, I guess. Anyway, hope everybody had a good Christmas and New Year's and everything, and everybody's doing fine. This is going to be kind of a mix mash video covering, hopefully I can get everything in here. I'm going to be talking kind of quick and stuff. The first thing I want to do, I was watching some videos, and something I wanted to talk about is about the inbox on YouTube, because if some of you have noticed, it seems to have disappeared. Normally you would go like to Video Manager and you would find over in here your inbox, but it's not there. Where you find it after you go Video Manager, go to Community, and under Community it's right there. That's where your inbox is. So for those who want to know where it's at, that's where it's at. They haven't got rid of it, but they managed to move it. I don't know if they're planning on eventually getting rid of it or what they're doing, but I guess it's to keep us on our toes. Now, Atwater Kent's together. At this point, it's not working right, mainly because of one of the RF tubes in here, the 22s, is dead. It's either got an open grid or a corroded grid lead on it, but in any case it's dead. It's attenuating the signal about as much as it would normally should amplify the signal. I know it's a tube mainly because there are 3 of them, and I have moved it around, switched it around with the other 2 that are good, they are amplifying, and the problem follows the tube. So the tube's bad. But that brought up a little point that I wanted to talk about. Now I'm going to just kind of really touch on it real quick. It deserves a video all by itself, but that's the differences between, say, a regular emission tester and something like this one here, the BNK that you've seen before. That's a transconductance or mutual conductance tester. And your regular emission testers, what they do basically, or at least the low end ones, like that Heathkit down there, and I got another one that's a Philco, they tie all the grids to the plate when they're testing. So basically what they're doing is they're testing the tube as though it's a diode. In other words, the only thing that's actually in operation is the plate and the cathode, and that's how they test for emissions. Where transconductance or mutual conductance testers, the grid is connected to a DC voltage supply that is a negative voltage, and then to get the mutual conductance they apply a AC signal to that of a certain voltage, peak to peak voltage level, and then they measure the current change in the plate. But what more importantly that does for you with the transconductance or mutual conductance testers is the fact that they're connecting different elements like the grid, and they'll actually connect the other grids up, a lot of them will, to other voltages too, to simulate as close as possible the tube in a real circuit situation. But it allows them also to be a lot more sensitive to secondary emission, leakage, which is the same thing, shorts, a lot more sensitive to different shorts in the tube, as well as open elements. Like if the grid is open, it'll pick up on that. And of course they're much better and much more sensitive at gas, testing a tube that's gone gassy on you, or has got some leakage of air into it. So that's about as much I want to talk about that, because I was testing them on the 22s on the emission testers, because right now that's the only thing I've got that's operational. and it tested good, but it's obviously not. So next month I'm going to get a tube ordered for this and get it in here, and then we'll get back to this and do a little more on it. It should be operational then, working just fine. The power supply is pretty much done. Basically, I need to get that tube in there because the plate voltages for the 22s, I won't know for sure how much current's drawn until that tube is operational too, so I can fine tune that for its final operation. Probably in the next video we're going to go over this one. This is that RCA K6-T6, which I think is actually a T6. The difference between the T and K, the K is a console floor model. The T is your tabletop model. I think this is really a tabletop model because the speaker connection line was fairly short. I don't think it would have reached to the bottom part of the console to the speaker. But anyway, it is working. I want to go over what I've got done on it. We'll probably I don't think it needs alignment. It's working really good, but I do want to go over some interesting things about it and stuff. Let's see, what else did I? Oh yeah, one thing. Watched some videos that kind of brought up something interesting I wanted to talk about, and that's meters. You know, a lot of people's got a digital multimeter like this, you know, different brands and everything, and comparing this to your average VTVM. Alright, first of all, most digital multimeters, at least your a little more higher end ones, say, I don't know, $50 and more, maybe $100 more. This one about $100 at Radio Shack. Excuse me. Will have a 10 megohm input impedance, so they don't really load real heavily on a circuit. But the thing I want to talk about is, like I say, most of these will be 10 megohms. Now there are some in certain brands that are specialty meters that can have 30, 40, 50, 60, or even 100 megs. They're high voltage digital multimeters is what they're used for, so they got a considerable amount increase in input impedance. Some of them can get up quite high, but your average one is 10 megohms. Now your VTVMs, and I don't care what brand it is, I mean, I happen to have a Master Votomus here, there's a Junior Votomus there, out in the garage I've got a Heathkit out there. They're all pretty much the same. On DC, and when I say on DC with the proper probe, because most of these on DC, the probe has got a 1 megohm resistor in it. This one didn't come with a probe, and I didn't feel like making one up, so I actually put the resistor on the switch so that when it's in DC, it's got the 1 meg tied in. But on DC, it's got 11 megohms. These will have 11 megohms input impedance, so they're really pretty much identical to the input impedance of your digital, so it really makes no difference between this and this as far as voltage checks. Now as far as doing alignment, it is still much easier to watch a meter, an analog meter, that needle move back and forth, than watching, you know, these little numbers switch on here. And and there's other problems that deals with that when you're doing. These are slow in changing their numbers. Even your top brands are a little slow. This is virtually instantaneous when that needle moves and you're making adjustments. But as far as voltage checks, as long as your VTVM is calibrated, you know, I mean, what it reads is actual voltage, you know, accurately, and your digital meter is accurate, then you're not going to notice any difference when you're checking voltages in your radio. Now, I do know that, you know, a lot of schematics, you know, have voltage charts. Now, the thing is, and I think this is where the confusion comes, is everybody thinks that these were wrote and the information on them was wrote from the standpoint of a VTVM, but they're not. It'll tell you that the DC voltage on this particular schematic from Sam's was done with a 20,000 ohm per volt meter for DC voltages and 1,000 ohms per volt for AC voltages. Now, where that comes from is a VOM. Now, VOMs are different. Excuse me. VOMs, and I brought up a picture of one. These, it's not a real good picture, but they're like this Simpson. They're a portable meter. They don't plug into the wall. They pick up their voltage. When they're doing voltage measurement, they're getting it from the radio or whatever you're testing. And you know, they have no vacuum tubes or anything in them. So, which makes them very portable. And back in the day, and more recently, these were the choice meters of your guys that was going out working on radios and TVs, because they were portable. They didn't have to worry about trying to find a plug to plug their VTVM in. Although RCA, and I'm not sure if anybody else did, but I do know RCA did make, excuse me, I've got a cold, so you have to bear with me. But RCA did make a Junior Votomus like that one there with batteries in it. But I think they were few and far in between. The spec sheet on that out of the book, this is a very poor copy, but it says 20,000 ohms per volt sensitivity on the DC. And the reason for that is, well, I seem to have lost my picture that I was looking for. There we are. Is right here, the schematic of it. And in fact, it's just the resistance on the different scales, the 20,000 ohms per volt, is coming from the voltage divider only that sets your different ranges. So that's where they're getting that from. So consequently, what that really means is at 20,000 ohms per volt, it loads the circuit by far more than, say, something like this or something like this. So in cases like that, you know, whether you use one of these or you use one of these, your voltage is going to be higher, as a general rule, than what is on the chart. Now, one last little thing that I want to point out is this particular radio, and a lot of times they'll tell you what it was measured on. I don't know if you can see it, but it says line voltage maintained at 117 volts. Well, that was fine back then. Here I've got quite a bit higher than that. I'm running between 127 and 130. A lot of people may be 125. But let's pick some numbers. Now, it's not going to be quite as important on something like this. This does not have a transformer. It's just series wound. No transformer, just a half-wave rectifier. So a little bit changes in the line voltage will be less percentage-wise throughout the radio, as opposed to, say, a radio like this with a transformer. Now, if we pick some numbers and play with some numbers here, let's say, just for instance, that the radio was, when they did the measurements and put it in the schematic, was at 115 volts. And let's say that you're plugging into your line of 125 volts. Let's say at your house it's 125 on average. That's a 10 volt increase on the primary. And let's just say that your primary to secondary winding ratio is 1 to 6. In other words, there's 6 windings on the secondary for every 1 winding on the primary. So what happens is the secondary is 6 times greater voltage. In other words, if you put 100 volts on that primary, you would get 600 volts on the secondary, or your B plus. And so now you've increased the voltage into the primary by 10 volts. Multiply that times 6 for the winding ratio. That's 60 extra volts that's on your secondary, or your B plus. Whatever percentage that works out to be will be the percentage increase of the plate voltages, and consequently screen voltages and maybe a few other voltages throughout the radio. Now, a lot of these will tell you that they do have a tolerance to measuring these voltages, what these are. This one happens to say plus or minus 10%. Due to just nominal tolerances in components. In other words, a lot of the components were like a 10% component, and so they're telling you that the voltages you get here could be plus or minus 10%. If you couple that with an increased line voltage over what the schematic says, plus the fact that you're using, say, maybe a 10 megohm or 11 megohm input impedance versus 20,000 ohms per volt or 10,000 ohms per volt or whatever, by the time you get all that figured in there, it could easily be plus or minus 20%, more probably to the plus than the minus. So keep that in mind when you're doing voltage checks, when you're troubleshooting a radio, that you may be measuring higher voltage than what it says on the chart. But if it's within 20%, it's probably okay. So just keep that in mind. But the thing I wanted to point out was there's no real difference between this and this. When they're talking about this, then what they're talking about is a VOM. Because that was what most servicemen used, because they were very portable. They were designed to be portable. And a lot of times when they came back to the shop, if they had to bring something back and work on it, they just used the VOM instead of some sort of bench equipment like these. So that's why most of the time they wrote these schematics up using VOM values. Anyway, I kind of covered pretty much. There's more stuff I want to cover. One other thing I want to talk about real quick. I've been getting a bunch of new subscribers, which I really appreciate, and thanks to all you new subscribers out there. But some of them are wanting me to do more videos on tube theory and radio theory and stuff, and I know some of you that watch my channel is not quite as interested in it. They like seeing the restoration of radios and stuff. So what I'm thinking about doing, trying to keep, try to fit in everything and keep everybody happy, is do, like one or two radio videos or restoration videos, and then do a theory video. Because some of the restoration videos I talk over about some different theories anyway while I'm doing them. The reasons why they did what they did, or something, and comparing schematics to the radio and stuff. So, but I thought maybe that might, kind of help and get everybody kind of what everybody wants. Some future videos I want to talk about is components, mainly capacitors more than resistors, because a lot of capacitors come in different packages, different color coding systems of telling their values, or what they're supposed to be anyway, and stuff. So I thought maybe I'd do a video on that to kind of explain, so when you look at, say, like a domino type capacitor or something like that, or a little tubular ceramic or something, how do you read that color code to know what size that's supposed to be? So I thought I'd go over that. Like I said, also I wanted to do a video on the tube testers and kind of something a little more in depth, the differences between them and how they work and stuff. And sometime down the line, it's not going to be right now, it's going to be after the weather warms up probably, because I need to work in the garage to do this. I thought, what the heck, you know, you see a lot of stuff on the internet about restoring a radio. Why don't we build one? Wouldn't that be kind of fun? You know, it may not work when we're done, but hey, it might be rather interesting, some of the problems we run into and some of the stuff they have to overcome. So I thought, from very scratch, you know, flat piece of sheet metal, I build up a radio chassis and see what that's going to take and entail. So that would be something further down the road, like I say, when the weather warms up. Anyway, I will get back to this. The next video, though, will be talking about this guy. So until then, thanks for comments, and I have been watching you guys' videos. I haven't had a chance to comment on a lot of them. I will try to, at least on the ones I feel like I got something to offer. But you guys are great, and I, you know, one thing I want to say is I am privileged and honored to be part of a society of this hobby, and having all you guys who subscribe to me and the guys I watch on there, and to be able to call a lot of you friends. It's a great privilege and a great honor as far as I'm concerned. So anyway, thanks guys, and I'll see you in the next video.